All right, so another thing you might see on an exam are some basic terminology, some basic vocabulary associated with an experiment. So, as with almost everything in this section, you'll probably see a blurb describing an experiment and asking you to identify one of these things. So, first definition we have are the experimental units. These are the items or subjects being given the treatment. If we're doing an experiment with humans, we will call them subjects as opposed to experimental units. But we could be doing experiments on mice or petri dishes, and in that case, our experimental units are the mice or the petri dishes. I hate this way this is written. I edited this in my other class, but I haven't edited it for you guys. So I really like to start more thinking about the response. At the end of the day, we are creating this experiment hoping to manipulate some outcome, right? Hoping to affect some outcome, hoping to cause something. That thing that we're hoping to cause, affect, manipulate, that is our response variable. You'll also see this called the outcome or the dependent. This is the thing that we measure at the end of the study. And our factors, there's a lot of definitions in one in this particular sentence, that's why I don't like it. Our factors are the variables that we think will influence that response. So all the things that we think might influence that response variable that we've collected, we will call our explanatory variables or factors or independent variables. We tend to reserve the term factor for things that we actually manipulate in the experiment. So things that we are actually changing as part of the treatment, not things that we're just recording. But explanatory variables usually encompasses all the things we're recording. So just know the response is at the end. Factors are the things that we're changing to make that cause that change at the end. All right, so levels are the specific values chosen for a factor. So that's why I say factors and explanatory variables are not necessarily a one-to-one, because our factors are things we manipulate, so we're going to choose exactly what the levels are. So I've chosen no homework, right? Text homework and online homework. Those would be the levels of my homework factor. The treatment is going to be all the different combinations of this. So perhaps I'm worried about how that homework, no homework is going to tie in with the type of classroom I have. So like right now, I have two different classes. I have 119 and I have 119X, right? So the class that is just a standalone, and I have the supported class. So maybe if I could do an experiment and randomly assign students to these two classes, which I cannot, I could randomly assign both the type of class and the type of homework. And in that case, when we're talking about a treatment, that's what one student got assigned to. If we were just talking about homework, it's as simple as the levels, if there's just one factor. But if there are two factors, it's all the combinations of those levels. So it will be taking 119 plus no homework. That could be something someone is assigned to. But you could also have somebody who's assigned to 119X plus no homework, because maybe it makes a difference. If you're in the supported class, maybe homework isn't as meaningful. But if you're in the standalone, maybe you need that homework. And so we'd have all the different combinations of this. Oh, I don't want no homework. I was like, what am I doing? It's the same thing. Text, and then 119X plus text. And then we'd have the same thing for the online. 119, that says test, not text. My goodness. And online, and 119X plus online. So we'd have 6 different treatments that students could be assigned to, right? So that's our definition of a treatment, is the combination of the factors. If there's one factor, it's literally just the levels. Control group, this is the people who are given no treatment. We'll talk about why this is important in a future video. But we do want to have a control group. The control group doesn't necessarily be no treatment, because like what does no treatment mean in the example above? But you do want to have at least a comparison group. You can't just do an experiment by giving everybody the drug. That means that doesn't help you account for certain things. If you're giving a drug, you do want to have a placebo or some sort of dummy treatment so that students, or subjects don't realize whether they're in the group or not. This is really important because there is such a thing as the placebo effect. I'm sure many of you have heard of it. And this is where people will have a physiological response to the idea that they're getting a drug that is going to help them. Just because they think it's going to help them, they will actually see physiological changes. So since that's the case, if it is something like a drug, we need to make sure that people think they are getting something. So that way we can account for the placebo effect. That's part of the reason why we need that control group. And the last of these definitions is blinding. Blinding is when people are unaware whether they're in the treatment or the control or which of the groups they're in. So in the case of a drug trial, having that placebo is giving us blinding, especially what we call single blinding, which is when the subjects don't know. But we could also have double blinding, and that's when both the subjects and the researchers don't know. So whoever is measuring whatever it is as our outcome doesn't know if the person has been in which group they've been in. So my husband actually works with one group at UCSD where it's called Open or Ask, and they're currently studying whether the way doctors communicate with patients makes a difference in terms of outcomes for those patients. I think just like patient satisfaction essentially is what's happening. So they randomly assign certain doctors to have certain interventions. Like some doctors, there's just a poster in the room telling patients what they should be asking about. In one group, they've actually trained the doctors in how to get patients to ask or how to deliver the same information. So there's the two arms, like this open, like, hey, you should just know what's going on. It's there. And then another one where the doctor asks them, are you getting everything? Do you have anything to go on here? And in that case, the response, the actual people who look at the surveys that come in, they don't know whether the person's in the open or the ask arm of the experiment. The patients don't know if they're in the open or the ask arm. The doctors do know because they have to, because they've been either trained or not trained based on which arm they're in. So anyways, blinding is super important if we're going to keep people from bringing in their biases and make sure that we are accounting for placebo effects. Another reason I think blinding is super important is if you had some sort of disease and you were hoping to get into a clinical trial to help you manage that, and they told you that you were in the placebo or the control group, I think you wouldn't stay in the group. As somebody who has a disease, right? I have rheumatoid arthritis, and if someone said, hey, we're not going to give you drugs, we're just going to compare you to the people who got drugs, I would say, no, thank you. Let me go back to the drugs I was taking before. That would be my response. So anyways, a lot of information. The next exercise is where we get to actually apply this and see how we did. So I'll break up the video here. If you want to, I would say try exercise 6 on your own. And then if you want to, just scroll straight to the end of the video and see how you did.